Welcome to the IpX True North Podcast, where we connect people, processes, and tools.
Welcome back to another True North podcast. On this episode, I'm joined by Dr. Nate Hartman again. For those of you that have continued listening to us, you know we typically just riff on topics of today that are impacting industry, governments, and education providers. And Nate, thanks for joining me. Today, I'm going to do it. I'm going to go down the rabbit hole of the new buzzword, and I know it's not truly a buzzword, but it tends to be at times: artificial intelligence, machine learning, and the like. Thanks for joining me, and apologize in advance for this discussion.
No, Joe. Thanks for being gracious enough to have me come back. You know, as the quote goes, since we're going down the rabbit hole, we're all mad here. So let's go ahead and get started.
Very true. We all, in some way, are a bit mad. Artificial intelligence. So let me just kick this off from a very simplistic Joe Anderson perspective. You know, I think we have surpassed the I understand where the fear is, you know, for future, you know, if we don't have the right protocols. But I really want to talk about, you know, what it means today, you know, and where it's come from. You know, we've had robotics for quite a while. You know, AI, the concept, you know, really kind of launched from a think tank, you know, over 60, 70 years ago. But when I look at artificial intelligence and some of the misnomers of, you know, of the types of AI and what machine learning is, what algorithms are, one thing I'd like to talk about in this episode is, and I don't know if, again, it's a consumer complacency or we're just so used to signing acknowledgments without actually reading them. But there's a lot of embedded AI capability in our products today. When we look from a data collection and storage and utilization and the algorithms behind that, you know, from a autonomous vehicle or your just standard combustion engine vehicle, we've got a lot of data, embedded intelligence in those products, our phones, our watches, our computers, and all of that's being retained in order to, quote unquote, give the user better experience. But in the wrong hands, and time and time again, I am reminded that no organization is truly safe when it comes to data protection. We've seen it from the health industry, the automotive industry, you know, the defense industry. There's nefarious individuals out there that are trying to use that data. And when we start thinking about embedded AI today and its functionality, I'd like to talk about that. But I'd also like to talk about, you know, potential benefits, you know, from machine learning and maybe in various industries. So I'm looking forward to getting your perspective, Nate. So just going to open the table up to you, and then we'll just go from there.
Okay. Again, recurring theme here in our podcast that, you know, these are some wide-ranging, deep, open kinds of topics. I guess maybe the first thing I would say is I think it's important to start with the idea that maybe of what we're not necessarily talking about at this point, because I think to your point about people's fears or misconceptions, concerns about this thing called artificial intelligence, we're not talking about a general global artificial intelligence that is its own sort of sentient force like a human being, right? That's not necessarily what we're talking about. You know, for those who are Marvel fans, right, we're not talking about Jarvis here. What we're really talking about is what's typically categorized as machine learning, which is a subset of artificial intelligence. And you know, again, not to get into some of the more academic nuances of it per se, but I think it's important to really put some boundaries around this topic because, again, to your point, people's minds will wander. People may potentially assume the worst, when in fact things like this can be useful. You mentioned, Joe, the idea that there's already embedded intelligence in a lot of the products we use today, right? Even something as simple as someone's web browser, right? And if you link together, for example, your web browser functionality to your social media profile, to your profile on streaming media sites and so on, all of a sudden you start seeing similar advertisements, right? Showing up on all of those things, right? Those are examples of, in the background, machine learning. There are algorithms that track where you look on the web, maybe the things that you buy online, the music that you might listen to, the movies that you watch, all sorts of things, even to some degree, things that you might post online, right? And so there are algorithms out there harvesting this. You mentioned for the benefit of the user experience, right? And generally speaking, that's probably a good way to characterize it, I think. They're meant to try to save us time, or they're meant to try to show us things that we might like, based on things that someone has assumed that we already like. Right. Again, based on our history there. But even now, you can buy vehicles, for example, right, with lane monitoring, with even some degree of autonomous operation, right? In fact, I just saw a television commercial last night. I don't remember which vehicle it was, but essentially it was someone sitting there with their hands off the wheel, vehicle driving down the road. Right. Now, that's not the same as, trying to eat your French fries and eat your hamburger and, steer with your knee. Right. But it's not that any of us have ever done that, but, the point is that, this was like a deliberate, autonomous experience. And again, there's a whole lot of technologies that go into being able to do that, right? But one of which is machine learning, connected to cameras and sensors of various sorts that analyze road conditions, the ambient light conditions, the behavior of the driver, all of those kinds of things, right? Even insurance companies today, right, offer discounts if you allow them periodic access to your electronic control module or whatever vehicle module on your engine, and allow them to download and analyze that data. So what we're talking about really are things that can, you use the phrase user experience, right? I'll use a somewhat different phrase, but very similar meaning, but it is meant to augment human capacity, right? We all know that human attention spans can be very short, but we also know that humans can store a wealth of information, right? One of the reasons why people have begun to develop machine learning and apply machine learning algorithms to different situations really has been around automation of sorts. And I don't necessarily mean factory automation or mechanical automation per se, right? Although certainly that's an example of this. Where machine learning can really help people in a working scenario is to help automate, or at least help augment, information processing, decision-making, differentiation between two conditions, two things, two scenarios, right? Human beings do have finite limits in their ability to process information. And so, unfortunately, though, that often tends to look like, or tends to manifest in people's fears of, well, automation is going to take my job. Well, It's possible, I suppose, but automation has taken human jobs throughout history.
Yeah.
Every industrial revolution has dealt with some kind of automation, whether it was mechanical, electrical,
Right.
whether it was cyber physical. Human beings have always sought ways to automate labor. I think what makes people uncomfortable at times in this conversation is now one of the things that we're talking about automating now is decisions. We're talking about potentially automating cognition of sorts. And so any process, one could argue, if it's a rules-based process, people can argue, well, that process, that decision, that thought could arguably be automated.
Correct.
And that makes people nervous.
Yeah, and and I'll maybe give some examples of those reactions. I'll play devil's advocate. I obviously see the benefit of automation and technology. As you said, it's been around for a long time. And I have benefited from it. But I am one that I turn off my microphone to apps. I turn off the tracking to apps. I don't need you to store my data. I appreciate you wanting to tell me when I need new toothpaste, or I'm running out of orange juice. If I had a smart refrigerator, there are refrigerators out there now that can scan the contents of your refrigerator and inform me when you're running low. And I see the benefits, but for this example, you also could store medicine in there. And do you want that data being stored and in a outside system, and a third party responsible for the security of that? And I think that's where that gray area. And then when we start talking about autonomous vehicles, I always use an analogy or an example. When I get in a ride share, I'm being driven somewhere, and that's a luxury. That's great, especially if I'm in the city or if I'm traveling. I don't have to mess with it for multiple reasons. The big one is if there is an accident, I'm not liable. Mm-hmm. If I'm in a subway, from point A to point Z, it's great. It's luxury. It's getting me somewhere faster than I could in a taxi or a ride share or walking or riding bike in a big city. But if there is something that happens during that transportation, I'm not liable. When we start talking about autonomous vehicles from a personal perspective, and this is something I've discussed with a few peers, there's this gray area, right, that I'm waiting to see what happens with the industry. Because if we go to the we've seen in movies, the true autonomous vehicle, where it is you get in and it takes you to where you want to go, who's liable then? Is it the service provider? Is it the manufacturer? Or is it the individual who owns the vehicle? And that's something I pondered. I think it's going to truly require the insurance industry to evolve. And I think how we if you're going to purchase an autonomous vehicle, you need to know those things. Mm-hmm. And I see that being a bit of an issue as well, because if I'm in a truly, the government says, yep, this is 100% autonomous, it's now regulated, you don't have to have hands on, you can sit in the back and eat your fries. Mm-hmm. Well, if there's an accident and it's that vehicle's fault, how am I at fault if I'm not driving? And those are things, and then the tracking and stuff you alluded to there, where and how do we model from an AI perspective? From a layman's perspective, when we start talking about modeling processes for decision making, typically that's an individual, that's a human doing the first base model, that baseline intelligence, that model that we're going to hand off to a machine. What are the controls in place there to make sure that model's unbiased, the process is unbiased, and also the data collection? Is that something that you see? We've talked about innovation in a prior episode. Do you see a need for us to put a little bit of research into how are we going to secure that model, the processing, some fail safes? So if we have a a model that's allowed to self-learn and self-adapt, what controls, what boundaries, how do we put guardrails in place for that type of intelligence?
Yeah, that's a really important question. And there's research efforts globally, mostly in universities, but in other places too. But it's certainly a situation where, we see instances even in our non-intelligent, non-machine learning environments and systems where, biases of some form or another have been injected into the process. And certainly, there's a lot of research on humans forming opinions, right? And humans forming biases. At their most basic level, biases are a sort of a defense mechanism. Now, obviously, we hear about some of the other malicious implications of those, right? But but to your point, there is an issue because that algorithm, that machine learning algorithm is not organically created, does not necessarily have a conscience in and of itself, does not necessarily have history and context in and of itself until it learns it. But it learns it in many cases, at least today, based on patterns. It learns it based on things that it can observe, if you will, with a camera or some other kind of optical device. And it requires the contextual parameters to be input by a human being in most cases, at least to start. And so, I suppose it's a natural question that someone would say, well, who's setting those initial boundaries, right? And what are their intentions? And so having, some kind of a guardrail to that system becomes incredibly important. And I think, again, there are a lot of, both here at Purdue and in other places, there are people researching, how to eliminate or at least control any sort of biases that an artificial intelligence or machine learning environment might have.
Yeah. And to add on to that, and most of our products today that have embedded software, as a consumer, typically, whether it's your phone or your vehicle, you acknowledge in the fine print that they're allowed to do software updates, and sometimes continuously, depending on the product, until they get it right. And this is near and dear to me. That's a product change. It could be transparent, but it could be a significant product change. You can do a lot with software. So when you start talking about some of those guardrails and safety mechanisms, where's the line when you talk about some of these live software updates or intelligence updates? How do we manage that internally from a change perspective? And what kind of guardrails do we have there for, that's a very significant alteration of the behavior of that in-field unit, whether it's a consumer.
Well, I think that's a good question, right? Historically, fit and form oftentimes drove engineering change, particularly in the case of product changes, right? Yeah. Oh, I might need to make this wall thickness a little thicker, right? Or this hole diameter a little smaller, or something to that effect, right? When electronics came along and we started having electromechanical kinds of products, again, there was usually a change in component. It wasn't until more recently that we started having, live software updates, right? If you wanted to change things, you'd swap out chips or electronic modules or what have you, and so on. I still think the concept of engineering change, or a change order or a change notice, that sort of stuff. Yeah. I still think that's going to be a thing, right? We're still going to have that. I think that the difference may come in, well, what is changeable, what is considered to meet the threshold of fit and form and function at the same time, right? You know, because to your point, you know, from a mechanical perspective or purely an electrical perspective, I might buy a product where all of the mechanical things and all of the electrical things needed for future enhancements are actually there, right? They come with the product. It's just a question of the software. Have I paid for the upgrade, so to speak, in order to enable now that device, whatever it is, to work the way I want it to work, right? If not, then those physical features stay dormant.
Yeah.
And so I think it's really going to cause us to redefine, maybe from a process perspective, what's the trigger for something qualifying as an engineering change?
It's when you put it in the context of AI and machine learning, where do you see what do you see the trend over the next, say, 36 months from a technological perspective? Where do you think we're headed? You know, I think we know, you know, I always define from an IpX perspective AI, and everyone has their own classifications. There's a few that are accepted, but for us, it's, you know, action-based, autonomous-based, and or adaptive. And I don't think we're at the Jarvis level of adaptive yet.
Right.
You know, we've kind of mastered the action-based, the robotics. We're going to program a machine to do tasks. We've got that pretty good. I think the autonomous, we're still figuring that out, you know, and I think the definition of autonomous changes depending on your industry. Where do you think we're headed?
In 36 months, it's hard to tell. I'm not sure, to be honest, whether we'll be much farther along the, you know, the automated or even the autonomous spectrum than we are today.
Yeah. So you're saying a lot of the fear that in the next 3 years machines are going to take over, the likelihood of that's pretty slim. And that's why I said 36
in my
months.
opinion, yes, because I think there's no doubt that as manufacturing, modern manufacturing, call it whatever you want, as that improves, there's always going to be, I suspect, some level of automation that might render someone's specific job to no longer be relevant.
Right.
Is it a global phenomenon? I don't know. I think it depends most likely on where you are on the globe.
Right.
I think what we're probably likely to see are things that might add more intelligence to edge devices, things that might make faster computation in the cloud. I think we'll continue to see the visual sort of graphical elements of a system continue to combine, you know, with the data and computational elements of a system, again, to better enhance a user experience, to make things, whatever it is, more usable. I think we'll continue to see environments where certain functionalities are app-based. The continued modularity of software systems, again, towards that app-like platform. I think, again, my opinion is that there's going to need to be some research work done on software engineering, on personal computing, in the sense that, you know, we've not had sort of these major leaps in everything from miniaturization to personal computing to sort of the software hardware interface. We've not had major leaps in a little while.
Yeah.
And I'm sure we will at some point, probably rather soon. But I think until some of those leaps in miniaturization and computing speed and the like, until those come to fruition, and I don't know that we'll see drastic improvements in the more generalized AI, right?
Yeah.
The stuff that you see in movies and entertainment, right?
Oh, yeah.
I think it's definitely going to remain, well, maybe not definitely, that's probably too strong of a word. It's likely to remain rather action-based until we see more of the development in that software hardware interaction space.
And I agree, and that's, I kind of figured we'd be like-minded on that. And for my perspective personally, I had a opportunity to attend a few NHRA races over the 2022 season, and I was able to spend some time with Mike Salinas and the team scrappers, and really look at that operation and how they use data and how they have machines that can monitor the weather, and tell them exactly how the car should be configured, exactly how he should drive that vehicle at that time. I mean, it's up to the second they're on the track. They're rapid data analysis. And I see a huge value in on the healthcare side, right? And being able to really fine tune our personal care. My hope is in the future we get to the point where with a prick of the finger at home, we can monitor where we're at. And if there's any anomalies with a public database, go, you know what, you're trending towards potentially some early onset cancer or heart risk.
Right.
I see that being a huge benefit, and it's something I look forward to. And then to talk about the job replacement, I'm seeing it. You go into over, I would say, the last 14 months is probably really ushered in with the pandemic. A lot of your grocery stores, your hardware stores, the self-checkout used to be just one or two aisles. Now it's rapidly expanding to almost they're all self-checkout.
Right.
And I see that. And then in some of our heavy industrial client base, a lot of robotics and machine moving in the warehouse, right?
Yeah.
You've got a lot of that. I don't see that going away. But the one thing I think individuals and our listeners need to understand is that's not cheap.
Right.
AI, machine learning, that's not a cheap investment. And the ROI isn't always there.
Right.
Initially.
And even now, with the state of the technology today, there's maintenance that has to get performed on that, right? And I don't mean like changing the oil kind of maintenance. I mean software updates, possible code rewrites, continuing to make it modular so that it, can more efficiently learn. Right. Those are the things I think that when people take on a project like that I don't want to say they don't think about it, but I have a feeling it gets underestimated, the amount of effort, time, cost, whatever metric you want, that it's going to take in order to do it.
Yeah. And, it's one thing that, from our education sector, we talk about BIM, right? Building Infrastructure Management and facility layout. And we work with organizations on the service side on when they're conceptualizing, the manufacturing floor, the facility floor of the future, and they're thinking about, we want to use this robot, that robot. We also have to remind them, once you lay it out with that mindset, it's a little more difficult to change, right? That site, there's a new investment on, we've built the layout of this facility to allow for these types of automations, this intelligence, this machine, this robot to move freely throughout. If we want to change a line, there's a little bit more we need to think about now.
Oh yeah.
And from a maintenance perspective, from a software and just from a layout change and a site change, there's a lot there. So I do think we've got to, as we discuss machine learning and artificial intelligence and where it's going to be applied, we can't forget the cost and the time associated with making these changes. They don't happen quick, which is what you discussed just a few minutes ago. 36 months, there's not a lot of potential true adaptive intelligence that we're going to see.
Right.
We're not going to see robots going to the grocery store for us in every household.
Right.
Which,
is there going to be improvements in data acquisition? Sure. Is there going to be improvements in visualization systems or optics? Sure. Right. I think what takes longer is that systems level integration of all of those things to come together in just the right way in order to get at that more adaptive kind of environment.
What do you from a education side of the house, where do you see, the AI capability being an opportunity for capability improvement or, process improvement?
That's an interesting question, because one of the challenges we have, I think, in an education environment is people want, and I think you could say this whether it's a formal learning environment even or whether it's an informal setting, is that sometimes people want to apply what we've learned in a production environment about efficiency and about efficiency measures and apply that to education. Now, I don't mean like K-12 education or university education. I just mean generally. Right. Generally, people want to try to apply that to education. But, I think it's important to understand that learning, human learning, I don't mean machine learning, I mean human learning, is often a very inefficient process. We can rapidly acquire things into memory. We can, even our senses, right, can rapidly feed us information. But comparatively speaking and figuratively speaking, it takes us longer to make knowledge, to make a memory of whatever stimulus just came through, right? And part of learning something is making a memory, whether that's mentally or maybe it's physical muscle memory, maybe it's a combination of both of those things. And so the element of time is important when it comes to learning. Yet time, in some ways, especially the more of it you have or the more of it you need, is often sort of the antithesis of efficiency.
Yeah.
And so I think one of the real opportunities, but also one of the possible challenges, is that because learning takes place on a very individual basis and the time scale is not the same for everyone, I do think machine learning or AI has an opportunity to maybe help us fill in some of those differences. For example, if you've got a classroom full of students, you're going to have some who learn really fast and they seem to comprehend the material really quickly, even to the point where they can apply it, right? You have others who they understand it, but they have a challenge of applying it. And there's some who don't even understand it, right? And the difference between those two ends of that continuum can sometimes be large. And as instructors or as teachers, one of the real challenges you have just from an operational perspective is the larger the number of people you have in your learning environment, the more likely you are to see some substantial spread between those who really get it and know how to apply it and those who don't.
Right.
And what often happens is you just practically and operationally speaking, you spend inordinate amounts of time on these people who don't necessarily get it, trying to get them up to a point where they at least understand it, right? And then often what that ends up meaning is that the students who do understand it and those who understand it and can apply it often don't get their skills, their knowledge nurtured in a way that some of these others do. And so where I think of one of the real opportunities is sort of this on-demand support, this on-demand help, if you will. For as long as we've been using PCs, right? Using computers, there's always been this concept of a help file, right? Well, what have we noticed, even in things as routine, so to speak, as our everyday office tools, right? They offer us help.
Yeah.
Sometimes we turn that off because we don't like it. It annoys us, right? But for those people who are learning something, on-demand help, meaning help and support, again, cognitive or otherwise, when I need it, right? Not before I'm ready to process it, and certainly not after the opportunity in which to process it has already passed, but I want it just in time, right?
Yeah.
So to speak.
Well, and you also want it to be functional. Some of my headaches of the help capability and systems is you spend more time trying to actually get it dialed into what you need help with. And I do think, with what we've seen with OpenAI and their chat capability, you now have a more practical, human-like help capability. So yeah, absolutely. I've tested it out a few times and quite surprised by the ability for it to actually, help. I used it to help, my son with some homework, for the times that I'm not there, because typically, like you said, if you're struggling with the concept, your help is doing the research first, right?
Yeah.
So I'm trying to train myself on a concept I don't actually understand that was taught to me. Breaking it down to an 8th grader's, math, having that help, AI assisted, and
Right.
from a machine learning perspective, it's got all the data points, but actually able to communicate with a human. The OpenAI functionality with their chat GPT or whatever it's called.
Yeah.
It is quite impactful. So I do see what you're saying. I hadn't considered it from that until I thought, I've actually used it in that manner, and it was actually helpful.
Right. And that I think is where, again, we're not talking about automating jobs away per se. What we're talking about is creating this more, again, a more systemic, a more assistive kind of an environment where human workers, whoever that happens to be, can get that support that they need, right? But we're also talking about, I think, more formalized learning environments too, where, again, there's usually one teacher to go around, maybe two if you're lucky, or maybe a support person if you're lucky, right? Well, those folks often cannot help enough of those students at once. And so using machine learning as an augment to that teacher's capability could be really useful.
And I think if you apply that same approach on the industrial side, when you start talking about, your line worker, we have standard work, work instructions, typically, those have been document centric in the past.
Right.
Any lessons learned has been almost the passed down, the tribal knowledge, so to speak. I do think there's a opportunity to invest in that type of capability where, and we talked about it in a previous episode, where our consumers are also providing us data on our products. If we have and we apply this to that kind of machine learning from a data perspective, we could have some on-the-job, real-time, assistant-level, AI capability.
Oh yeah.
And I think that to me is, we already got some augmented reality, and some of our clients more advanced manufacturing and even on the service side. But I think having a live almost assistant, for types of issues, that could be quite powerful.
Well, and that can help in a number of ways, right? I mean, again, a lot of the manufacturing companies that I talk with here, they're having trouble finding people.
Yeah.
So, you could give your existing employees, your ongoing employees, support, right? Or once you do find someone to hire, how do you get them up to speed? Well, how do we normally do that today? There might be some kind of a training program or onboarding program, but it's usually, go find the person who has been here the longest and have them teach you.
Yep.
Sometimes that's not particularly efficient. Sometimes it's not particularly good either. And so,
in my experience, it's normally both.
Right? Yeah, right. Yeah. And so I think one of those things that it could do is help in a situation like that. It can also help, I think, in a situation where compliance is important, regulatory or otherwise, where you may be audited at some point, right? And one of the shortcomings that human beings often have is when they're doing a task and they've more or less mastered how to do the task. Well, now it isn't about, the novelty, if you will, of learning for the attention system is gone.
Yep.
Now it's more about, this is something I just have to do. Yeah. I already know how to do it. People often use the phrase, I can do it in my sleep, Yeah. Well, you probably shouldn't. Yeah, and so, when you have this, any kind of a situation where there's like an auditing or a compliance requirement, machine learning can, again, or even AI could be used in a situation like that to help make sure that whatever the activity is that the person does, it remains in compliance.
Yeah. And I think, to tie it into our previous episode about assessments, there's also the ability to use some of that assessment data and some of the learning modules to create a virtual training assistant for onboarding.
Yeah.
And, and honestly, offboarding as well. And, when we have attrition and, the retirement class of individuals, there's knowledge there, and that's a lot of what from an IpX that we specialize in, it's knowledge management. And when we think about AI and how it relates to the future of knowledge management, I think we're just on the, the infancy of that.
Yeah.
But
I would agree.
I think for our audience, for our listeners, as we close out this episode, just to clarify, we're not stating that, the future of AI doesn't have some potential pitfalls or dangers. We're not saying that we need to not keep those on the horizon. Mm-hmm. We understand we're talking about now and understanding and make sure as our audience and as like-minded individuals, we're looking at ways to not only utilize these capabilities, but also provide the right guardrails.
Right.
And, for me, it's the guardrails are very important, because, you don't want them to be too restrictive, but if you just open it up, that's when you run into security issues. But
right.
Nate, another great conversation, another great podcast. Thanks for joining us. For our listeners, stay tuned. We have a few more great sessions or episodes coming up with Dr. Hartman. But for this episode, thanks for joining us, and we'll talk to you soon.
Thanks, Joe. Looking forward to it again.
Thank you, Nate.
Thank you for tuning in today. Don't forget to subscribe and review the show. And for more information on IpX, visit ipxhq.com.